For our next class, we will be taking a quiz, so this video is just going to go through what's going to be on that quiz. So the first thing we looked at in this unit are the parent functions and transformations, and we actually looked at 7 parent functions. The first one we looked at was linear, which is our line, right? And our parent function is y equals x, and that goes from the bottom left to the top right through that origin, right? Then we looked at quadratic, which is y equals x squared, and that is our U-shape, our parabola. We've looked at square root, which is the square root of x, and that's our swimmer's arm. We've looked at cube root, which is the cube root of x, and that is our S shape. And then the opposite of that is our cubic, which is x cubed, and that one is our snake, which is the opposite of the cube root. We've looked at exponential, which we say our parent function is 2 to the x. That's just a simple one. The parent function changes. That's our curve. And don't forget we have that asymptote where the graph approaches but never touches. And for the parent function, it's at the x-axis, or at y equals 0. And we also looked at absolute value, which is very similar to our quadratic. Remember, absolute value is distance from 0, and that's our V shape. Right? Along with these parent functions, we looked at different key features. So some of the key features that you're going to need to be aware of, we filled in on that chart, are domain and range. Right? Domain is the x value, range is the y value. We looked at end behavior, right? What's happening as the graph goes to the left and as it goes to the right. We looked at absolute and relative max and min. We looked at even versus odd. And we looked at our x and y intercept. And remember, you can look at your graph to find it, or if you plug in 0 for y, find your x-intercept, and plug in 0 for x to find your y-intercept. So make sure you're aware of all of these shapes and our parent functions, and as well as the key features. The other thing we did with graphing is we looked at the transformations. And remember, we had all these different letters. So we'll come up here. We start with H and K. Those are our translations, so side to side, up and down. So H is our horizontal, so that's left and right. And remember, it's always the opposite sign. K is our vertical, and it's the same sign. So H is always inside the parentheses with the X, and K is on the outside by itself. So that's left, right, up, down. We also looked at A and B. A is our vertical stretching and compressing, so that's making it skinnier, fatter, going up and down. And B is the opposite. That's our horizontal stretch and compress, and that's the opposite of vertical. So if you're stretching vertically, that's the same as compressing horizontally. All right, so they're opposites. And then we also talked about A and B, if they're negatives, that's going to be reflecting. So a negative A reflects vertically, so you're reflecting up and down, and a negative B reflects horizontally, so you're reflecting left and right. So make sure you're aware of all these transformations, the graphs, key features, and all that stuff for each of these parent functions. We also looked at inverse functions, and we had 2 steps whenever you're trying to find the inverse function. Step 1, switch your x and y. Step 2, solve for y. So for the first one, we have y equals 4x minus 5. First thing I'm going to do is switch it. So we get x equals 4y minus 5. Now I want to get y by itself. So I'm going to start by adding 5. So we get x plus 5 equals 4y. And then I'm going to divide everything by 4. Alright, so then I'm going to get y equals, now because neither one of these divide by 4, I'm just going to leave it as x plus 5 over 4. If it's simplified, I might have kept them individual, but it really doesn't matter. So the inverse is y equals x plus 5 over 4. For the other example, I've got f of x equals x cubed minus 2. I'm just going to rewrite that as a y, so it's easier to see. So y equals x cubed minus 2. And now I'm going to switch my x and y. So x equals y cubed minus 2. First thing I need to get rid of is the 2. So x plus 2 equals y cubed. To cancel out a cube, I'm going to cube root. So then I get the cube root of x plus 2 equals y. And that is the inverse for x cubed minus 2. Then we looked at inequalities, just basic inequalities. So for this first one, I have an OR, right? So I'm just going to solve both of these inequalities and then look to see if I can consolidate. So 3x plus 2 is less than or equal to negative 4. I'm going to start by subtracting the 2. So 3x is less than or equal to negative 6. And then divide by 3. So x is less than or equal to negative 2. So that one's done. I'm going to bring my OR down so I don't forget. Over here, I'm going to subtract the 4. So 4x is greater than 20. Divide by that 4. And so we get x is greater than 5. So x is less than or equal to negative 2, or x is greater than 5. I'm going to look at my number line. So the negative 2 goes on the left, the 5 is on the right. The less than or equal to gets a closed circle, and I'm going to shade to the left because that's which way it's pointing. My greater than 5 gets an open circle, and I'm going to shade to the right because that's where it's pointing. And I can't consolidate these. So I'm going to leave my answer as x is less than or equal to 2, or x is greater than 5. For the second example, I have the compound inequality, which looks like the and, because I have 2 less thans and I have 3 different parts. So I'm just going to solve, but make sure that whatever I do to the middle, I do on both of the outside numbers. So I'm going to start by subtracting the 5 from all 3 sides. So negative 3 minus 5 gives you negative 8. And then I'm left with just a 2x. And 17 minus 5 gives you 12. Then I'm going to divide everything by 2. So negative 4 less than or equal to x less than 6. And I'm just going to leave it in that form. Keep in mind when you do inequalities, if you multiply or divide by that negative, you've got to switch your sign. Then we looked at absolute value equations. So we're switching back to the equal sign. Remember, absolute value is a distance from 0. Alright, so the first thing we got to do is isolate our absolute value. So for this one on the left, it's already by itself. Then my next step is going to be to write my 2 separate equations. So one of my equations for this first one is going to be 3x plus 2 equals 1. And then 3x plus 2 equals negative 1. So these are my 2 equations. So on the left, I'm going to subtract 2. So 3x equals negative 1. Divide by 3. And we'll leave it as x equals negative 1/3. So there's one of my answers. Same thing on this side. Subtract the 2. So we get, oops, sorry, that should be a negative. So we get 3x equals negative 3. Divide by 3. X equals negative 1. So my 2 answers are negative 1/3 and negative 1. On the other example, I have to get the absolute value by itself. So I'm going to start by getting rid of the 2. So I'm going to add 2 to both sides. 4 times 2x minus 1 equals 36. Now I've got to get rid of the 4, so I'm going to divide. So we get the absolute value of 2x minus 1 equals 9. Now my absolute value is by itself, so I'm going to split it up into 2 equations. So I'm going to have a positive 9 and a negative 9. Now I'm going to add 1 to both sides, so 2x equals 10. Divide by 2, x equals 5. So there's one answer. Over here, add 1, so 2x equals negative 8. Divide by 2, x equals negative 4. And those are my 2 answers. Then we looked at absolute value inequality. So we're going to take what we just talked about with absolute value equations and merge it together with our inequalities. So for the first one, same rules apply. I can't do anything until I've got this absolute value by itself. So I'm going to add 1. So 2 times the absolute value of 3x minus 1 is less than or equal to 8. And then get rid of my 2 by dividing. So the absolute value of 3x minus 1 is less than or equal to 4. So 2 things you have to remember. Less than or less than and equal to is always and. Greater than or greater than or equal to is or. Alright, so in this case we've got an and. So for the and, all we do is drop down that equation without the absolute value. And then I'm going to put my opposite on the other side. So over here I'm going to have a negative 4 with that same inequality sign. Now I've got my compound inequality. I'm just going to solve like we did before. So add 1 to all three sides. And then divide by 3. So we get -1 less than or equal to x less than or equal to, and we'll leave that as 5/3. Can't simplify. And over here for the second example, my absolute value is already by itself. It's isolated, so that part's done. And I've got a greater than sign, so that means I'm working with or. So if we have or, we're going to have two separate inequalities. So I'm going to have x plus 4 is greater than 5, or, and then I'm going to do x plus 4 greater than the opposite, which is -5. Subtract 4. So on this side, x is greater than 1, or subtract 4. X is greater than -9. Now anytime we have or, we want to look to see if we can consolidate. So let's see, the smaller one's -9, the bigger one's 1. Both of them have an open circle and both are pointed to the right. So that looks like the -9 overpowers the 1, so my answer is just going to be x is greater than -9. It includes the greater than 1, so we don't have to write both. And that's everything that's going to be on your quiz tomorrow.